All right, so lesson 41, adding like terms and rational expressions is the first part. This is going to combine a bunch of stuff that we've already learned. It's going to combine, excuse me, what we've learned with adding like terms, x plus 2x equals 3x, right? It's going to also combine those expressions, those terms that look like fractions with all those variables, and we're going to write them all exponents positive, which we just did a couple days ago, or all exponents negative, which we did that same day. And so to do that, when we do these, we end up creating common denominators, and then we can add things up. So it's good. I won't lose you, but it'll be a little bit complex. And of course, take a note of our cartoon. Rock and roll. So here's our first problem. B times x, so first time, divided by term, divided by x to the third, y to the negative second, minus 3b y squared x to the negative second, plus 4y squared divided by bx squared. So that's our very, very first term. As it is written right now, as you're writing it down, as it's written right now, it is not so easy to determine if these are like terms, but they are. Looking at them right now, do they look like terms?
Yeah, I can tell.
You can tell that they are.
Yeah, because the y to the negative second, that would become positive.
I haven't told you that you have to do that, though. Okay, so you have an inkling that this is going to work. Well, of course it's going to work, otherwise I wouldn't show it to you. But there's a trick to this. And the trick to doing this problem so that they all look like terms is we're going to write it so all of our exponents are going to become positive. All right? So let's rewrite this so all our exponents are positive. Okay? Can we handle that? All right, so let's look at the first term. This the y squared here is not positive, so how do we make that positive?
Bring it up.
We're going to bring it up, and that's going to be y squared, right? But, and the b can stay right where it is, but we have an x on top and an x to the third on bottom, and we need to get those onto the same wavelength. So which one should I move, the top x or the x to the third on the bottom?
The top one.
I need to move the top one because I want to keep them all positive, right? Because that's what I told you to do. So we're going to move this one down. So 3 minus 1 is 2. So now we have x squared. First term is done. Everything's positive. Our second term. There's only one thing that needs to be moved in our second term. X squared, right? So that's going to be 3by squared. We move the x to the negative second down to make it positive, and now it's x squared. Then, we're going to take on the bottom, what needs to happen on the bottom? Can anything happen on the bottom? The bottom has to stay because I said everything positive, right? So on the bottom, I have 4y squared b x squared. All right? So far, so good? So what can I do on this problem? What can I solve on this problem?
The first two.
Okay, the first two are like terms. How are they like terms?
Because they're the exact same.
They are the exact same. All right, so I have, even though we don't write it, even though we don't show it, this is a 1, right? Even though we don't normally put it there. That's going to be a 1. So what is 1 minus 3? Negative 2. So our new problem is going to say negative 2 by squared over x squared. And since this one's different, because our denominator is different, that we leave alone. and now it's solved. Okay? So when we do these problems, and sometimes you have to work them another way. So I'm going to rewrite the exact same problem here. I'm going to rewrite it because I'm going to upload the slides too. I discovered I can do that too. Bx, same exact problem. Now, same exact problem, all exponents negative. All exponents negative. So when I do that, on my first term, what is the first term going to look like?
You gotta move the b and x down.
Okay, I move the b and the x.
Wait, no, you
No, I
gotta
don't.
move the
The
x
x
on the
won't
bottom
move.
up.
Okay, so the x on the bottom is going to go up. That's -3 plus 1, -2, right?
But
That's
the b
good.
has to go down.
X squared, so it's b to the negative first power, y negative squared.
X
Correct?
negative
Yeah.
x.
Yeah, thank you, I didn't write the negative. Right? Good catch. Now, for the top part,
The b and y go down.
okay, the b and y go down, the 3 stays. So 3x to the negative second over b negative first power, y to negative second. And then the final part, what happens with this one?
The b and x go up, the y goes down.
The b and the x, okay, so I get 4, b to negative first, x to negative second, over y to negative second. And again, which 2 terms can I add? I can still only add the first 2 terms. So what do I get on this one? I get negative, so it's negative 2 x to the negative second over b to the negative first, y to the negative second. Notice the denominator doesn't change at all. Okay, we're going to leave it alone. Plus, what's the plus?
4 b negative.
Good.
X.
Okay? Does that make sense? I'll give you guys a chance to try one in a little bit. All right? So we did the problem, the exact same problem 2 ways. All exponents positive, all exponents negative. The book will tell you which way it wants you to do it, though. Okay? It will suggest to you which way to do it. Questions on that part? Okay, there's a second part to this lesson. And the second part is 2-step problems. All right, so 2-step problems. Every time I hear 2-step, I remember in PE when I was in high school, we had to learn the 2-step. Dance. It was always not fun because I don't like that kind of music, but that's how I go. So here's a 2-step problem. Here's the first part. X plus 3 equals 7, and what is x minus 8? All right, so before we can solve what is x minus 8, we have to know what x is. So we do this part first. So how do we do x plus 3 equals 7?
Minus 3 to x.
Subtract 3 on both sides. Very good. X equals 4. Now that I know that x equals 4, what is x minus 8? What is 4 minus 8? Negative 4. That's a 2-step problem. Is that hard? 9? 9, 9? 9, 9 for outline. All right, one more. X minus 5 equals 7. What is the value of x plus 4? Before we can do x plus 4, we have to do x minus 5 equals 7. And as you just said, we add 5 to both sides. X equals 12. 12 plus 4 equals
16.
16. And our two-step problem is done. Questions on that? Cool? All right. So I'll stop this recording, and I'm going to give you guys a chance to try, practice. Oh, here's my seat. Squeeze in my seat. To try practice B, all of you. I should have paused it, I stopped it. Oh well. Oh, it didn't? Cool. It didn't stop. This B. All right, so here's practice B. The rule for this one that the book is telling us is all variables in the numerator. Doesn't tell us all positive, all negative. It says all variables in the numerator. So what we have to deal with are these three parts. All right? I'm going to rewrite them twice. Okay, so let's do the first one. We're going to move the b to -9, and we're going to move it up. All right? When we do that, we do the reciprocal, which is not -9. It's going to be +9. So that is a to -8, b squared, b to the 9th. And I'll simplify this when I'm done. You could write over 1, but it's not necessary. On the next one, I have 4b to 11th, and I'm moving the a up as +8. So that's going to become -8. So a to the -8. And then on the last term, I'm going to move a to the 8 up and b to the 5th up, and they're both going to become negative when I do that. So this is 6b to 11th, a to the -8, b to the -5. With me so far? Okay, all I did was move stuff up and change the signs. In essence, that's what I did. Okay, because I'm doing the reciprocal. Now, on each of those three terms, I'm going to combine each term part first. So when I do that, I get a to the -8th, b to the 11th, because 2 plus 9 is 11, minus, nothing to do on the next one, 4b to 11th, a to -8, plus, I'm going to write 6a to -8, because that's by itself. Now, b to 11th and b to -5th power is 11 minus 5, so it's b to the 6th, you're right. The first two terms are the same, the last one is different. So the last one I leave alone, but the first two I can combine. 1 minus 4 is -3. So I get -3, a to -8, b to 11th, plus 6, a to -8, b to the 6th. That's done. That's all I can do to it. So in this lesson, at least this part of this lesson, what we did is we combined what we've done in several lessons, adding like terms. We have moved our exponents using that property of the multiplicative inverse, the reciprocal, and solved. Okay? The book will tell you exactly how it wants you to do these. All right, so make sure you take advantage of that. That is telling you that information.